All right, here we go. So trapezoids and kites. Like I said, today's lesson, we could probably call this part A if you wanted to do that. All right, so we are just going to talk about trapezoids today. Now, we've already talked about trapezoids in the past. We haven't learned a whole lot about them. We learned a little bit about them. All right, so let's just review briefly what we know about a trapezoid. Remember what it looks like? Let's do this. All right, so this kind of looks like a trapezoid. Tell you what, I'm going to make it look a little different, just to make sure it doesn't look like something else. We're going to talk about it in a minute. All right, there you go. Now, can I say that that's a trapezoid right now the way I've written it? Sure looks like a trapezoid if you remember what trapezoids look like. But can I say with 100% certainty that that's a trapezoid? No. Why not? What has to be true about a trapezoid? Do you remember? It hasn't been that long since we talked about it. It's only been, I don't know, maybe a week or so. 2 pairs? Just 1 pair. Exactly 1 pair, okay? Exactly 1 pair of what? Parallel sides, okay? So if you have a 4-sided figure, a quadrilateral, right, and it only has 1 pair of parallel sides, then that's a trapezoid, all right? Write it down. What if a quadrilateral had 2 pairs of parallel sides? What would that be? It's not a trapezoid. Come on. Are you guys here? If you had a quadrilateral, okay, and you had 2 pairs of parallel sides on that quadrilateral, 2 opposite sides are parallel. Well, it could be a rectangle, but it's not always a... No? You get a quadrilateral with no parallel sides. Thank you. A parallelogram. We've been talking about parallelograms so much. I mean, it seems like that's all we talk about are parallelograms. I thought that would be the first thing that popped in your head. But that's okay. This right here is a trapezoid, all right? Now, we know, let's see, really just about a normal everyday trapezoid, we really don't know much about it. We know some names for some of the sides. What do I call this side and this side? I give it the same name. Call it the leg. Okay, so that's a leg and that's a leg. So the non-parallel sides are called legs. What about the parallel sides? What do we call those? Called a base. So that would be a base, and this would be a base. Everybody with me? Okay. I think that's the only thing that we know about a trapezoid. But we do know something else about a specific type of trapezoid. Do you remember what we had a specific type of trapezoid that we've talked about? Let me try to draw that. Say that again. A regular? I don't think we called it a regular trapezoid. Again, I'm going to try to draw this so it looks like what I want it to look like. So there. It may not be perfect, but it's pretty close. But if I did this, it'll be fine. Very good. If the 2 legs were equal to each other, then I call this a what? It's not a parallelogram. I only got 1 pair of parallel sides. It is a trapezoid, that's true. Okay, it's an isosceles trapezoid, right? It's an isosceles trapezoid. What does it mean to be an isosceles trapezoid? That's right. You got 2 sides are equal, and it's always the 2 legs. It's never the bases. Everybody got that? It's always the 2 legs that are equal, not the bases. That would be an isosceles trapezoid. Make sense? Okay. So, I don't think that we really talked about anything else on this isosceles trapezoid. Do you remember anything specific we talked about? I don't know. Well, you guys didn't even know what a parallelogram was, so I don't know why I'm asking you this. But anyway, I think that's it. I think we just said that was an isosceles trapezoid. I can't remember what else we said about it, but I will do some more stuff. So that's all old stuff, all right? That's what we know already. It's not a whole lot, but it's a little bit that we know. The new stuff that we're going to learn today is this. I'll tell you what, let's let's do this. I didn't do it in the other class because I didn't think about it. But do you remember if I had an isosceles triangle? Do you remember that? Okay, that would be an isosceles triangle. What did we know about some of these angles if I know that's an isosceles triangle? Okay, they are acute. They don't have to be acute. You could have an isosceles obtuse triangle. So that's not necessarily true. Oh, and what were you saying? Are they? On isosceles? If it was equilateral, if all three sides were equal, then all the angles would be the same. But what do we know about the angles that are opposite the two equal sides? No, angles are not parallel. They're congruent to each other. That's right. Okay, so this angle and this angle right here would be equal to each other. Everybody see that? The opposite angles are equal. We kind of have the same thing that's true here, kind of. Okay, there's a lot of similarities between trapezoids and what? Triangles. Not just that they both start with TR, all right, but there are similarities. We have isosceles triangles. We have isosceles what? Trapezoids, right? So look at this. This is kind of the same. See, these two sides are equal. The opposite angles are equal. Well, check this out. You got isosceles trapezoid. Those two sides are equal. That must mean that these two angles are equal. So that's new. That's today. We're just learning that today for the first time. Zion, writing all this down? Yeah? It's kind of hard when your arms are all inside your shirt like that. All right, so these two angles are equal to each other. And guess what else? If these two angles, and these are called base angles. Base angles. All right, both of these right here. These are also called base angles. Now, they're different bases, right? But that's also called a base angle as well, even though it's up top here. So if these two base angles are equal to each other, guess what's true about these two base angles? They're also equal to each other. So we have a theorem that says that the base angles of an isosceles triangle are congruent. Let's write that down. The base angles of an isosceles trapezoid are equal. I'll just put the equal sign. Or you could say congruent. Same thing, basically. Not exactly, but it's close to the same thing. All right? So if I call this trapezoid ABCD, then I could say what? That angle what is equal to what? Let's do the bottom ones first. Angle D, it's not angle DC. It's just angle D is equal to angle what? C. Good. Give me another set of equal angles. You got it. Angle A equals angle B. That's easy to see, isn't it? Everybody got that? All right, that's pretty important. Okay, we're going to use that. We're going to have an example in a few minutes that we're going to use that. So keep that in mind, that the base angles are equal. Let's talk about something else. They don't talk about it in here, but we should be able to figure this out. If these two sides right there are parallel to each other, tell me something about these two angles. What's the relationship between these two angles right here? There's something in common with them. They're supplementary. Very good. How do you know that they're supplementary? Because they're next to each other? Well, this one and this one are next to each other. No, this one and this one are next to each other. Give me a good geometry reason. Say what? Watch. These two are parallel lines, right? I'm just going to kind of draw this separately. That's a transversal. Would you agree? All right. Where's angle A? Angle A is right there. Where's angle D? It's this one right here. You're on the right track. Keep going. If you put the two together, right? Consecutive interior angles. Okay? They're consecutive interior angles. What do we know about consecutive interior angles? They're supplementary. So what's true about angle A and D? They add up to 180. Good. Okay? So you could say that angle A is what? Supplementary to what? To angle D. Now, angle A would also be supplementary to something else. It's equal to angle B. Angle C, right? Because D and C are exactly the same, aren't they? So if A is supplementary to D, then A is also supplementary to what? Angle C. You got it? Yes? All right. That's important too. For instance, if I said angle D was, let's make it easy, let's say it's 50 degrees. If angle D was 50 degrees, tell me what angle A is equal to. Actually, tell me all four angles. If angle D was 50 degrees, you should be able to tell me the other three angles. Okay, this would be 50. That would be 50. What would angle A be equal to? 30? 130. Okay, good. It's 130. We're going to write that down. And then angle B would also be 130. Everybody with me on that? But you know they're not always going to just give you numbers, right? They're going to give you terms of x, right? They'll say this is like 3x plus 1, this, all that kind of stuff. So keep that in mind, okay? You know they're going to do it. They've done it before all year. They're going to keep doing it, all right? So it's just with different figures. Really, the geometry really has not changed since we started learning it this year. It's just the shapes are different. That's it. All right. We're doing the same kind of thing over and over again. Have you felt that? Right? You got angles, you got angles equal, you got sides equal, you got things that are supplementary. So you add them up, set them equal to 180, you set them equal to each other, solve for x, plug it back in, right? Haven't we been doing that all year long? Yes. Okay. And we're going to keep doing that. All right. That's what this is all about. All right. Enough of that. Let's do another one. Let's draw another one. It's kind of messy on that one. So this is also isosceles trapezoid. Well, actually, I don't know yet. All right. So I do not know that this is an isosceles trapezoid. But here's something that I do know. They tell me, all right, that this angle and this angle are equal to each other, and they tell me that this and this are parallel. That's all they tell me. They don't say anything about the sides being equal. They don't say anything about these two angles being equal. That's all they tell me. Is that enough to say that this is an isosceles trapezoid? It is. Because if you have a trapezoid, how do I know it's a trapezoid? Because I have exactly what? One pair of parallel sides. With me? All right. So I know it's a trapezoid. How do I know it's isosceles? Because this angle and this angle are equal. And what's true about base angles of an isosceles trapezoid? Or what's true if I have base angles equal to each other? It must be a what? An isosceles trapezoid. Because check this out. If those are parallel, then this and this are supplementary, and this one are supplementary, so those two would be equal. So look what I have. I got two pairs of base angles that are equal to each other. So guess what this is? This is a what? Isosceles trapezoid. Okay? All right, enough of that. Let's continue. Let's go to white again. Let's draw another isosceles trapezoid. All right, and this is, well, it's not the last thing it's the last thing today that we're going to learn about an isosceles trapezoid. But we are going to do one more thing with a normal everyday trapezoid. All right, so I tried to draw this so that this and this were equal. And if I told you that, then what do I have here? I got a what? I got not just any trapezoid. What is it? It's isosceles. Now, check this out. We did this stuff with parallelograms. We did it with a rectangle. We did it with a rhombus. We did it with a square. Look at that. What is that thing I just drew right there in red? It's a diagonal. Good. All right. What I want you to do, call it A, B, C, D. I just want you to guess, and I'm almost sure that you're going to guess the right thing. Almost sure. What's the relationship between those two diagonals, AC and BD? What do you think? What does it just look like? It looks like they would be exactly the same, doesn't it? And they are. In fact, they are the same. And it's a theorem. Okay, I'm not going to go through like why it's true. I'm just going to tell you what the theorem is. All right, so if you have a isosceles trapezoid, and if these diagonals are, if you have diagonals of an isosceles trapezoid, then they are equal to each other. So what could I say here? I could say that AC is what? Equal to, look at it. Here's AC, and it's going to equal what? BD. Good. All right? And that's the theorem. If you wanted to write it down, it says, it basically says this. It says the diagonals of an isosceles triangle I'm going to spell it right. Isosceles triangle. Oh, it's not a triangle. What is it? It's a trapezoid. Okay? When isosceles trapezoid are congruent or equal to each other, it's fine. All right? Did you write that down? Half of you didn't, because half of you got your heads on the desk. Maybe not half, but more than should be. All right, enough of that. That's all I'm going to say about that. Now, let's do an example. I really hope you're awake for this one, because there's a lot to this. Let's draw it right here. I'm going to draw an isosceles trapezoid. Let's scooch it over a little bit. And we're going to put some values in here, and this is an example. Okay, it's example 2. I don't know what I did with example 1, but this is example 2. And let's put some diagonals in there as well. And I'm going to put some values in here. So I'm going to tell you that that's 30 degrees, that little angle right there. See this big angle right there, that whole entire thing? I'm going to make that 125 degrees. And that's it. Let's label it A, B, C, D, and E is right where they intersect. Yeah, I think that's all they give you. All right. Oh, they tell you one more thing about the sides. We're not going to do that till the very end, but I'll write it down. That AC is equal to 7x, and that BD is equal to 4x plus 12. I'm not going to write that in here. It just gets too messy. All right, so I'll just write it off to the side. So here's what they want you to find. They want you to find the following. You writing it down? Don't make me do all the work. You want to find BAD, then angle ADC, and then angle ABD. ABD. So you want to find those, and there's a little bit more. You want to find an angle ACD, ACD, and then AED. Man, I didn't know there's that many angles in here. And then the last one, you're not finding an angle, you're just finding a side, and that's what you want to find right there. All right, here we go. Right there is good. Let's start off with the first one, angle BAD. We got to find where it is first. There's B, there's A, there's D. So what are we trying to find? We're trying to find that whole big angle right there. Everybody with me? All right, snap out of it. Kid Zion, okay? Zion, wake up. Come on, pay attention. All right? Have a little respect for yourself. All right? Sit up, watch what's going on, write it down. If you're writing it down, you won't be sleeping, okay? I'm telling you. All right, so we want to find that angle right there. So that's kind of easy. See if you can figure it out. It's not kind of easy, super easy. What are you speaking, Klingon or something? It sounds like you're speaking another language. Nah, come on. It's super easy. I'm telling you. You're overthinking it.
All right, so 50. All right, so B.
No, it's not all right. Just look at it and just say, oh, it's boom. What is it? Why? That's it. Because these are base angles. Look, angle A and angle B are congruent to each other.
So DC is
Look, we just did it right here. Look. See, these two angles are the same, aren't they? Would you agree? All right. So what's different?
Nothing.
Nothing's different about it.
C is 50, A is 125.
So this is also 125. And that's this right here, BAD. See, BAD, that's that big old angle A right there. That's 125. You didn't have to do any math at all with that, right? Because they're base angles. You got it? Okay. ADC, where's that? ADC. That's this whole big angle. It's doing a different color. So I got to find that whole angle right there. 60? Why? Because you went 30 and 30? Who said that this was bisecting that angle? Nobody said that. We didn't say it today. So this and this angle are not equal to each other. All right? Subtract what by 180? No, don't add 30 anything. 30's got nothing to do with that yellow angle. To find the yellow angle. What's true about the yellow one and the red one? Let's go back again. Let's go back in time. What do we say about this angle and this angle? They're supplementary, right? Okay. So you just take 125 away from 180. You got it. So in order to find the yellow one, we just go 180 minus 125 because they're supplementary, right? I know this is new. You just learned it, but it should be in your notes, right? If you took notes, it should be right there. You should just look at it. You don't have to slide to the top like I did on mine, all right? That is 55. And so that's this, ADC. ADC, that's this whole big yellow angle, is 55 degrees. Everybody see that now? Now, just for the fun of it, if you wanted to, I don't even think they asked for it, though. How would you find this little angle right here? That's right. Okay, I don't think they asked for it, but that'd be all right. Let's find it. 55 minus what? 30, which is 25. Again, they don't ask for it, but let's just put it in there anyway, because they could, right? They could ask for it. You never know. All right, let's keep going. ABD. Let's go to a different color now. Where's ABD? ABD. That's this little skinny one right here. It's not the whole big 125. It's just that little bit right there. How'd you get 30?
It's alternate interior.
Very good. I like that. That's awesome. I didn't even have to ask you. You told me right away that this and this are alternate interior angles. So this is 30. Or yeah, this one down here, they gave it to you as 30. So what's that one? That's kind of a mess. But anyway, that would be 30 as well. Okay? So ABD is 30 degrees. Make sense? All right, what about ACD? Change colors. ACD, that would be this one right there. Yeah, that low John right there.
125.
That little angle right there is 125?
It's 30.
Yeah, it's 30. Because look, I still have not, I got to figure out why this is true. And for some reason, I got a roadblock. Maybe some of you guys could see it. I can't think of an exact reason why this and this are equal. But if you look at it, like that whole diagonal is equal to that whole diagonal, right? So where they meet, it's not halfway, okay? But this will equal that. And I'm struggling to find a good reason for that. Well, we're going to find that in a little bit. So I'm not really, I wish I could give you a great reason why. I don't think you care anyway, but this little angle right here is going to be the same as this one. So if these two sides are equal, these two opposite angles are equal, so that's also going to be 30 degrees, just because that one's 30 degrees, okay? So that would be this one right here, 30 degrees. I really got to come up with a good reason for that. What color haven't I used yet? This orange. Let's use that orange. Yeah, black wouldn't work too well on this. All right, AED. So AED, which one's that? That's this one right here. Does that look orange or does it look red to you? Kind of looks the same color as red, doesn't it? Let's do the pink. Or is there any other color I haven't really used? This purple? What about that purple? Okay, there we go. That's, yeah, that looks different, doesn't it? All right. Yes. Yeah. Man, I wish one time somebody would raise their hand and contribute to the discussion. But all right, here we go. This one right here. Now, let me remind you of something. We haven't done this in a while. Everybody watching? Do you remember this? Remember this was, excuse me, this was an exterior angle. What's the exterior angle equal to? It's equal to what?
120.
No, there's no number. Because I don't have any numbers here. Okay, which inside angles? This one and this one. The remote interior angles, do you remember that? The exterior angles equal to the remote interior angles. We have that situation here. Do you see it?
Yes.
Because look at this triangle. See this big triangle right here, EDC? Yeah. This is an exterior angle to that triangle. Yeah. So which ones are the remote interior angles? 30. Yeah, this 30 and this 30. So to find this purple one, all we got to do is just add them up. That's it. 30 plus 30 is this angle right here, which is 60 degrees. So this angle, shh. Okay, let's stop being goofy. Come on, let's be serious students. So that would be 60 degrees. All right? Here's another way you could have looked at it. Let's watch. Here's another way you could have looked at it. This is 30 and that's 30 and that's 60. Look at that triangle. 30 and 30 is 60. This angle right here would be what? 30 and 30 is 60. Take away from 180. So this would be 120. So if this is 120, then you could find this exterior angle, couldn't you? Because this forms a straight line. And that's also 180. So you could go 180 minus 120. But that's kind of silly to go 180 minus 60 is 120. And then 180 minus 120 is 60. Okay? You could have just added these two up and said that that was 60. That's a better way. That's why we learned this thing right here. And then we got all the angles. We got one more thing to do. They don't have anything to do with the angles. They're just sides. So, now let's do this in yellow. Look what they tell you. They tell you that AC is 7x. Check out AC. Let's make this a different color. Stop with the noise. All right, so there's AC. It's 7x, correct? And BD is also congruent, isn't it? See the two red ones right there? They're equal to each other because we just learned just a little bit ago that the diagonals are equal to each other. Got it? That's it. So what are you going to do over here? You're going to go, let's do it right here. 7x equals 4x plus 12. That's it. Okay, something we've been doing all year long. Subtract 4x from both sides. That gives us 3x. Divide by 3. X is 4. 12 divided by 3 is 4. Yeah, just wait till we finish this. Okay, so x is equal to 4. Is that my answer? Do I put a 4 right here? No, because it asks for AC. AC is what? 7 times 4, which is 28. So AC is 28. There you go. Now look, let me say this. Listen to me. Do not put degrees here. Why not? It's a side. It's not an angle. It's a side. It's not an angle. You should put what on these? Degrees. On many of the quizzes, many of them, listen to me. Shh. Hey, stop. Let me talk. Many of the quizzes, I circled, or I put a little degree symbol there because you're forgetting to do that. All right? Maybe you're just lazy, I don't know. Or you just forget about it, I don't know. But you got to start remembering to put the degree symbol. I've talked to several teachers in the past, geometry teachers, and they told me that they mark the problem wrong if they don't put degrees. You might get the whole problem right, did all that work, and you got whatever you got on one of these. I mean, none of these were really hard, but let's say the 60-degree one, right? And if you just put 60, even though that's the right number, the teacher would mark it wrong because you did not put degrees, all right? I am not that harsh, all right? I take pity on you, But I'm telling you that there are some teachers that will do that. So make sure that you think about that when you write down an answer. Okay, if it's an angle, always put degrees. If it's a line segment, listen. If it's a line segment, then do not put degrees. I can't tell you how many times I've seen on quizzes where people put the answer is a length of a line segment and they put degrees here. Does that make any sense at all? Does AC being 28 degrees make any sense? Not at all. Again, details do matter. You're absolutely right. All right, so I'm trying to teach you. Now, I could probably do a better job at teaching you this if I mark the problem wrong for you not putting a degrees there. Maybe I could teach you better by doing that. I'm trying to help you out by just telling you about it and having you do it. But I'm telling you that there are teachers out there who will mark that problem wrong because you didn't put degrees. Or they'll mark this one wrong right here because you did put degrees and it shouldn't be there. All right, so be careful. Think about what your answers mean, all right? And don't put degrees when you don't need to. You need to make sure you put degrees when you're supposed to. I got 5 minutes. I got one more thing to do. All right, this is a little different, but it's similar to something that we talked about a while back. That does not look isosceles. Actually, it doesn't have to be isosceles. Right, this does not have to be isosceles, so it's completely fine. Watch what I'm going to do. I'm going to take this side, and I'm going to find the midpoint. On this program, when I highlight that side right there, it gives me that little blue dot, and it tells me where the midpoint's supposed to be. So that's kind of nice. Of course, I got to click off of it first. There we go.
Serious question. So, are we doing things like with the base and stuff again?
We are.
So, base at the top, base at the bottom?
Yep. And that's going to be very important. It's a good question. Thank goodness it wasn't a bathroom question. But you're absolutely right. We are going to do something with the top and the bottom. All right, everybody look up here. Shh. Let's quiet down, okay? I'm going to start writing stuff up, okay? I've been letting stuff go. I've been pretty cool about this, but I've come to a point where you just are taking advantage of me, all right? This is not going to happen. I hear other teachers. I hear the teacher this over on this side, and I hear you guys in Spanish on that side over there, just going buck wild, all right? It's not going to be like that in here. You understand me? So let's put an end to it. Shh. Shh. Stop. Let's put an end to it and pay attention. I got 3 minutes. Pay attention.
Sir.
So this thing right here, I connected the midpoints. We'll call this M. We'll call this N. We'll call this A and B and C and D. All right. This thing right here is called a mid-segment. A mid-segment. We've actually done that with a triangle before. Okay, I'm not going to go through that because of time. But we talked about this in a triangle. Now remember, you have bases. This is a base and this is a base. But they're different bases. So I'm going to call this base 1. I'm going to call this base 2. Okay? So we have a little formula. Well, there's two things that are true about this mid-segment. One, if this is a trapezoid, those are parallel. What do you think this mid-segment is? It's also parallel. It's not congruent to any of these. It's not the same length, all right, but it's parallel. Everybody got that? Here's the one thing that's super important. That the mid-segment, we'll call it MN for the mid-segment, is equal to, it's kind of like the average of two things. It's kind of like the average of the two bases. How do you find the average of two things? If I give you two numbers and I say find the average, you sum it up, okay, add them up, and then divide by how many you have. If you have two things, you divide by 2. So let's sum them up. B1 plus what? B2. And the average would be over what? That's it. So, for instance, if I'm just making a number up here, let's say this is 14. Let's see, this is 6. Okay? Everybody watching? Okay, check this out. If I wanted to find the length of the mid-segment, so they say, find MN, what would you do? You go, no, you got to add them up first. Add up the bases. 14 plus 6, and then do what to it? Divide it by 2. So that's 20 over 2 is 10. All right, now look, listen to me. I don't know if anybody ever does this, but you need to. All right, we've run out of time, so I want you to watch the video from the first class. Just go to the end. Don't watch the whole thing. Just slide the slider thing to the very end. Right after this, I do an example. All right, and one of the sides is like 4x plus 2. This one is 10, and this one is 2x. Watch the example on there, okay? We're still not finished. So your homework is 1 through 12, and it's section 6, what is this, 5? Section 6-5A. So that's your homework. That is due tomorrow. Watch the video on that last example, okay? We didn't get to it today. So watch the other class. They're the red class, okay, on the YouTube. And then you should know how to do it.